Okay. Okay. Hi, my name is Osama, and today I'm going to share with you some security research that I've been doing over the past year or so, and how you could defeat remote code exploits this time for good. Just a few things before we start. If you have questions, we're going to cover a lot of material. So if we can, we'll have questions at the end. And because we have a lot of questions, a lot of demos, and a lot of material to go through. And the second thing, are there any pen testers or red teamers that brought their laptops today? Okay, great. We have about 17 exercises you could try to break in. So and if you get that, there's a reward for anyone that could break in. Copy of this book. Okay, let's get started.
Is that the PHP, the PHP mod security? Or is
it's mod security in general, yeah. Okay, a little about myself. I previously led InfoSec and AppSec in a major telco. I currently work in security consulting, AppSec, cloud security, infrastructure security, and InfoSec in general. I'm a key contributor to the OWASP Top 10, the OWASP Proactive Controls, and the OWASP ASVS. Does anyone use any of these? OWASP Top 10? OWASP Proactive? OWASP ASVS? I'll just wait. No one uses the OWASP? Okay. I'll just give a second for these. Okay, so the proactive controls, if you're not familiar with them, they basically tell the developer how to think about security. It's not just a list of watch out for these things. It's how to think about input validation, how to leverage security frameworks, and so on. The OWASP ASVS is probably the coolest OWASP project, in my opinion. It basically takes all the security requirements that you typically need in an application and breaks them down. So regardless if you're a developer and you need some checklist to use, or if you're auditing an application, or if you're talking with third-party developers and you need to make sure that they build security in, it's a great project. If you're doing pen testing, or if you have a third party that's doing pen testing, it's great to make sure that they adequately cover your project. Mod security, I'm the technical reviewer for this book. It's a great WAF, but we're not going to talk about it today. Okay, moving on. Okay, remote code exploits execution. Remote code execution, in a summary, is a superset of all web app vulnerabilities. If an attacker is able to compromise your application through a remote code exploit, they have a shell. They could do anything you can imagine. They could steal your source code. They could inject malicious code. They could do SQL injection, steal your data. They could attack other applications on the same server. They could do privilege escalation, and they can pivot internally. A lot of breaches start by something small, and then attackers moving laterally in your network. For example, Equifax, the biggest breach last year was just a small support portal, which they used to breach basically 150 million users' not credentials, but social security numbers and identity. So some of the high-profile examples from last year was Equifax data breach. Anyone use Drupal? Drupal developers? Yeah, there was a pretty bad remote code exploit that was in Drupal core that affected about 1 million sites. And any PHP developers? Yeah, okay. So anyway, this was about 2 months ago. There was a remote code exploit in the main PHP package manager. So moving along. Okay. Remote code exploits isn't just a specific vulnerability such as SQL injection or XXC. It utilizes a number of different attack vectors. You have direct injection in case of sloppy or insecure development. That's what happened with the PHP breach. XXC. You have insecure deserialization. Everyone's familiar with deserialization? Yeah? Okay, good. By the way, there's a great talk if you're not familiar. There's a great talk in AppSec 2015 about deserialization. Deserialization is horrible it's great for attackers. It's horrible for defenders. You also have components with known vulnerabilities. Struts. Anyone hear about the struts vulnerabilities last year, the year before. Okay. So all of these vulnerabilities can actually result in remote code execution. You also have additional attack vectors that aren't covered here, such as expression language injection and server-side template injection. File upload vulnerabilities. If you aren't securing your file uploads, attackers can upload web shells and compromise your servers. And finally, you have remote file inclusion. Okay, so what are security teams currently doing against remote code exploits? You have a ton of attack vectors. It's difficult to actually do anything, and it just keeps going on forever. If all the time you get an alert, okay, there's a third-party library we're using that's vulnerable. We have to go patch it, and then you have to get into internal. You have to get approvals. And it just keeps going. It's exhausting. It's a bit like refactoring your code for forever. It's not a lot of fun. So, moving along. So this is a question I asked: is why does this keep going? We've had a lot of improvement in things like SQL injection. SQL injection, if you notice, it keeps going down because frameworks, ORM frameworks, make things a lot easier. Even in things like cross-site scripting, you have frameworks like Angular that are making things a lot easier. CSRF, all frameworks now out of the box support it, so it's not an issue. But remote code exploitation is something that there are no good solutions now for. So the question is, why on earth does something like a Tomcat or Node.js or PHP have to execute any command on the operating system? So I thought, okay, what are possible solutions that I could look into? First of all, fix the source code. That's not very practical. Software is imperfect. You've got a ton of third-party libraries. Even if you write the best software there is, you can't protect against it. You've got legacy code. So this hasn't worked for the last 20 years or so, so that's not a good solution. Okay, maybe we could look at WAFs. The problem with WAFs are very useful, but they're not very useful for what we're looking for. They would require re-architecture. They can't detect things like dynamic code. Go ahead. No problem. So we can't use WAFs. How about something like runtime protection? Some languages like Java give you a runtime protection component that you could use to protect your application, but that's language specific and it's application specific, which means that it's a lot of overhead and maintenance. Moving along. So we have to go deeper. I thought, why can't we look at how to prevent this at the OS level? I mean, if an attacker is trying to do remote code execution, they're going to have to run operating system commands to pop your box. So the great thing is the operating system sees everything. It works. If we could look at a solution at this level, it works regardless of the higher level language. We don't care if it's Python, if it's Java, it's PHP, if it's Ruby. It doesn't matter. And it's attack vector agnostic. If the attacker is using deserialization to get in, it doesn't matter. If they're using remote file includes upload or file uploads, it doesn't matter. So it requires no changes to your apps, zero code modification. So that looks promising. Okay, when I started looking at this, we're going to have to go a little into more details, and we're going to have to look at some things that are OS specific. Okay, what I thought of is, could we understand how remote code exploit / process creation actually happens at the OS level? If we can intercept this, and then if we can whitelist just things that our application actually needs. System calls. This is just a quick overview of how system calls work. Everyone has an idea about operating systems and how system calls work? Yeah? Basically, your application needs to read a file, it needs to run a process, it needs to send a packet request or use TCP/IP. All of this is done at the operating system level. It just uses your application uses libraries to make system calls. So all of this is done at the operating system level, and the operating system can intercept this. It could approve or deny this. By the way, do you know Julia Evans? This is probably the most useful Twitter account currently available. I'd highly recommend you follow her. She takes a lot of concepts and breaks them down into like small, cool graphics like this. Okay, so what are the system calls that we have to look at to detect process creation / remote code exploits? There are actually only two. There are actually 300 syscalls on Linux, but we're just interested in two. They're fork and exec. These are used for an application to create a new process. So the best approach, I'd have to do one of several things. I'd either have to build a kernel module that intercepts all of this and looks at a whitelist and approves, or I have to look at a different solution. Writing kernel modules isn't something that I look forward to, and I'm really bad at C. So I decided to look at a ready-to-use solution. Linux security modules. Anyone do system admin on Linux? Okay. Okay, great. You guys might have heard about Linux security modules. Basically, it's an additional layer of security in Linux. You have your traditional Unix permissions. A certain user could run X, but you don't have very granular control of what you can do. That's where Linux security modules work. They provide basically sandboxing capabilities for your applications. The most popular are SE Linux and AppArmor. So I decided to try to see if I could use these. SE Linux. Anyone use SE Linux? Okay. Actually, who has a mobile, an Android mobile? All of you have SE Linux. All of you use SE Linux. Okay, it was developed by the NSA about 20 years ago. And basically, very basically, it does labeling. That's how it does security. So if you everything has a label. A process has a label, and every object on the file system, every port has a label. And it's just basically a number of rules. This process, or a process with a specific label, can do X on a file or a directory or a port that has a specific label. Here's an example. HTTPD, that's a process name. It can read files that have this label. Okay, so it's extremely powerful, and that's why Android has adopted it as the security framework that they use. Here's the great thing is that there are hundreds of profiles that we could use out of the box. You have profiles for Nginx, Apache, Passenger, Tomcat, and you have profiles even for databases, CouchDB, MongoDB. So everything I'm covering here, you could apply not only to web apps, but also to databases and other infrastructure that you're running. It's also really a little complex. You have about 97 different objects that you could label. You have a lot of permissions, and it's typical, sorry. And out of the box, you have about 100,000 rules. That's a typical distribution. That's all done for you, so that's great. But there's a problem. The default policies don't actually protect against remote code exploits. They severely sandbox a user. So even if I run something against Tomcat or PHP, and if they're using SE Linux, there's very little I can do. So I decided to re-architecture the default policies to add remote code exploit protection. This is a little technical, so I won't cover it here. I'll cover it in a blog post. But let's see what this does. Everyone loves demos. Sorry. Okay. Sorry. Is that good? Okay. Okay, basically what I developed a profile. I'm going to show you what things look like before and after. I took 8 vulnerable applications. 8 vulnerable applications. I included a web shell. I included deserialization to just prove that this protection has nothing to do with the type of web application vulnerability. Okay, this is the list of exploits that are available. By the way, I'm going to give you a link right now after the demo where you could actually try these different exploits. So this is a list of exploits that are vulnerable applications that I'm exposing. Okay, so as a defender, we found that we have all of this, and we can't change anything because of change process that takes months to get approved. We hope just that no one finds this. Unfortunately, someone did find it. Okay. We download the exploitation scripts and YSO serial. YSO serial is just a common a tool that helps you do in deserialization attacks. Okay, so let's try to exploit this. First, we're going to try first with the command shell that we found. It's a web shell. Okay, we ran ls. We get the results back. We'll try some of the different exploits that are available. This is just like a Spanish exploit developer. I'm not good at Spanish, but anyway, we got our shell and we'll run Tomcat. And so we're on the other box. This is a struts vulnerability that was released about 2 months ago. And again, it works. Now we're going to try a reverse shell and actually get a shell on the box. We create our serialization attack using YSO serial. We set up our listener. By the way, it's a little fast. I'm going to actually publish these if you want to try them out. So, okay. If you notice, we're down. We got a shell here. Okay. So now that was without SE Linux. Now we're going to implement or enable the profile that I developed. That's it. We just enabled it, set enforced. Now we're going to try everything again. We got a 500 error. We didn't get our exploit running. Let's try some of the others as well. Again, this didn't work. Our command shell didn't work. Okay, that's the demo. Sorry. Okay, just think about that. We took basically a ton of, there were a total of 8 remote code exploits. Using SE Linux, we basically disabled all of them. And it's not just 8, it's like 100. And any Java-specific remote code exploit, we just blocked it right there. So that's pretty nice. So if you're an enterprise, you could basically package this as an RPM, distribute it on all your servers, and then even if there's an exploit next month, it doesn't make a difference. Okay, this is if anyone actually wants to have a shot at this live. These are demo apps that we used. Is the URL clear?
Which networking? Oh, just
yeah. Are you guys able to access this? I'm going to keep them running over the weekend even, so if you wanted to. Okay, so here we'll just try. And I included an exploit script that you could use so you don't have to actually waste time looking for the exploit. And even some notes on how to use the tools in case you won't, to make it fair. Here's an example. Here's a command shell that is one of them. We could try to run ls, and it doesn't work. So you guys could try all weekend. It doesn't make a difference. But if you do get it, you'll get a copy of this. Okay. So what are the pros and cons? That's the first of 5 approaches we'll look at. Okay, the pros and cons. Pros, it's very sophisticated. It's been around for 20 years, and it's great for intrusion detection. And even without my extra remote code exploit coverage, an attacker can't do a lot, even if they got onto the box. Now the cons, it's not easy to learn SE Linux. It has a steep learning curve. It's not container aware, so If most of your infrastructure is containers, it's not going to be that useful. And it's not well supported on some distributions like Ubuntu and Debian. So we want to look at other solutions as well. If you want to look more into SE Linux, I'd recommend these resources. Okay, so if you are, anyone use Debian or Ubuntu? Okay, this is like the SE Linux alternative that you could use. It's AppArmor. It's similar, but a lot easier to use. It lets you control file access, execution of applications, and so on. And let's jump straight away to the demo. I won't go into the details, but the demos are always nice. Okay, here we're going to show one advantage that AppArmor has. It's in that you could use it to protect your containers. Unlike SE Linux, it's container aware, so I could take a Docker container and protect it. So I'm going to install two identical Docker images. One of them is both of them are vulnerable, but I'll add our AppArmor profile to one of them. Okay, the exact same Docker container. I ran both of them, but the only difference is that I attached our custom profile to it. Okay. Now we're going to attack both containers. They're identical apps. Sorry, can you see the bottom of that?
The bottom is cut off.
Okay, sorry. That was good, right? It's the exact same app on both of them. We can get our exploit script, and we're going to try to run a command. This is on the vulnerable one. Exact same command on the other one. It just redirected us to the main page because it wasn't vulnerable. Okay, that's the end of the demo. And if you want to take a shot at trying to break in, here's the IP and here's the application. Moving along. Okay, so AppArmor. What are the pros and cons of AppArmor? It's much easier to use than SE Linux, and it supports containers. So if you're using Docker or Kubernetes, it's great for that. It can block some kernel exploits, and even if it doesn't block an attack, you could use its logging for intrusion detection. The cons, there are fewer profiles out of the box, so you'll have to develop a lot by yourself. And the documentation isn't great. Hopefully, I'll be releasing some documentation related to creating your own profiles. And if you're using Red Hat, if you're using CentOS, you can't really use it. Okay, so now we've seen two solutions, SE Linux and AppArmor. Both of them are really good at things, but they also have limitations. For example, you don't have one that works on all Linux distributions and can look at and supports containers. So what do you think we're going to do now? We need a single solution that could do both. So I decided to develop RCE Guard. It's a universal remote code exploit detector. What I basically do is utilize something called the Linux audit framework. It's something in the kernel that I could ask to forward system calls to me. So I could tell it, whenever you see someone creating a process, tell me about it. So I take this, and then I allow you to define rules when it should alert you that something's wrong. Let's look at an example. Or actually, the rule language is very basic. It just tell it what command you're interested in. For example, I could tell it, okay, all the Java processes, I want you to monitor them, and it'll monitor them. And I could tell it, okay, they're whitelisted things that I know my application runs, and there's no problem. And I could give it an app name if I want to. Here's an example of a rule. Super simple YAML. You just define the rule. You define if you want an exact match or partial match. So this gives it flexibility. For partial match, I can just give it Java, and it'll monitor all Java processes. I can tell it what user to monitor. I'm just interested in Java if Tomcat's running the Java process, not if some user is just compiling or running their own Java. And here's an example of a partial rule. Does anyone notice something different in this slide from the previous, besides the partial part? Yeah, make it easier.
Whitelist.
Sorry?
The whitelist. It'll kill the process.
Yeah, exactly. There's a whitelist. I think, oh yeah, there's a whitelist, and I added an option that you could actually kill the process. This isn't inline. This is like a 20 millisecond delay that it'll actually execute before it's killed. On to the demo. Oh, 1 second. Basically, I'm just setting up things. I'm telling the kernel I'm interested in things related to process creation, forward them to RC guard. And it could monitor anything. Because the operating system sees everything, it can monitor containers, and it can monitor normal processes. So it's as simple as running PS. I could either take all of this, everything I see related to the command, which is Docker, Java, home run, Java, or I could just take part of that and use that in my rule. Okay, that's a rule. Could you see that, or is that? That's just the same rule that we saw before. I tell it, I'm interested in monitoring Java. I want partial matches. User is root because this is a container. And I tell it, okay, ls is okay. Any other command you have to, I want to be notified about it. Okay, now I'm just going to tail the log file and start. First of all, it looks through all the current processes and adds them to the list of processes that will monitor. Okay. It gives me things like the host name, message, app name. I could customize it so I know which app was compromised or someone tried to compromise. And it gives me as well the rule that was matched. So I could forward all this as JSON to my SIM, for example. Okay, this is just, it told me a process was monitored. Okay, now we're going to simulate just an attacker. We're using the web shell that we used before. If we ran ls, it succeeded. If you notice straight away on the right, RCE guard detected ls being run. So this is near real time. You have about like a 20 millisecond delay between a process running and us and detecting it. Okay, it tells us allowed process detected, which is what we expect. After you do the tuning, you could tell it just to tell you if there's a remote code exploit. So if something's whitelisted, it won't tell you about it. So you could just get purely alerts if something malicious is happening. Okay, now we're going to try a non-listed command like df. It runs. Remember, this is out of line. So if a process just takes 20 milliseconds or less, we can't kill it. Okay. Okay, here we're just going to update it to kill any rogue processes. I just added a lot of comments because so when I share it, people know what's happening. Okay. Okay, now we're going to try a reverse shell. What do you think will happen? Will we get the shell or not? Sorry? You'll get part of the shell, but you won't actually be able to do anything. Yeah. So that's what happened. It starts the shell, starts sending the stream, but we can't interact with, it hasn't even sent it and it's killed. RCE guard, you could basically deploy it on all your servers and just tell it, okay, just monitor all the Java processes or Node.js or whatever you're using. And you basically get a ton of signal with next to zero noise. Okay. Okay, that's it for this demo. I don't remember what the end of the demo looked like. Okay, so moving on. Here are the pros. Easy to deploy. You could deploy it in minutes. You could customize it regardless, because we're looking at things at operating system level. We don't care at all about what application server is running, what process is running. Super simple language. Works on both containers and normal applications. We get real-time alerting with basically zero noise. And it lets you, it's the only one that actually lets you whitelist specific commands with parameters. SE Linux, AppArmor, the rest, you just tell it, okay, I want to run Java without specifying the parameters. You can't tell it, okay, I want to run Java with specific parameters only. SE Linux CGuard lets you do that. The cons, the attacker has about 20 milliseconds of execution time, and there's just like a slight overhead due to the syscall logging. So could we do better than that? Any ideas?
Yeah.
Okay. What? Okay. Actually, we're going to see something I think is one of the coolest tricks in AppSec history. This. I wanted to try minimizing our exposure to not to zero, basically. So the idea was, instead of trying to control processes in memory, what it could run on by looking at syscalls, I'm going to do so at the file system level. So in a nutshell, I want an application to launch, Java or whatever. It has full access to all the executables on the file system. As soon as it launches, I want to revoke all of that. Okay? So there are three components I'm going to use for this. Systemd, which is already used for running all your services. I'm going to use something called POSIX ACLs. Not a lot of people are familiar with them. But these basically let you just add additional access control on files. And I'm going to use a timing trick. So I'm going to allow the process as full access to do whatever it wants as it's starting. As soon as it's starting, give it like 10, 20 seconds to read all the, to run anything it needs. And then I'm going to revoke that access. Let's look at a demo. Here I'm going to disable SE Linux. SE Linux has nothing to do with that. This is just us. These are the three files that will do everything. We're just looking for all the executables on the file system and putting them all in a file that we're going to then process. Sorry. Okay, so now we have a list of all the executables on the file system. No problem. And this is a list. This is our script that's actually going to revoke Tomcat's access to all these executables. I'll give an example of whitelisting just a specific command that we want our application to use, like df, for example. It's just hypothetical. We update our systemd configuration. And that's it, basically. 1 second. Okay, we're vulnerable. We just, in the 20 seconds or whatever timeout, we specified that it's still, you could still get remote code exploitation, but as soon as our ACL kicks in, we're no longer vulnerable. You get that? Here we give Tomcat a few seconds to start up. When Tomcat starts or any process starts, it typically runs a few bash scripts to set up the environment. As soon as that's finished, we run our set FACL and revoke access. So it currently has 0 access to anything on the operating system in terms of execution. So now it's finished. It was vulnerable. Now if we rerun it, ls and all the other commands aren't available. But the commands that are whitelisted, that we whitelisted, still work. Okay, moving along. So basically what we did was emulate everything, not everything, but an important part of what SE Linux and AppArmor do in about 15 lines of code. And this is our third challenge. If you guys want to, this is basically the same 8 vulnerable applications we protected in SE Linux, but you use our technique. Only the df command is whitelisted. Okay, so pros and cons of this solution. It's extremely simple to deploy. You could actually do this basically to protect any application in about 5 minutes. There's 0 overhead while it's running. There's 0 overhead. And it can be used alongside other technologies, other techniques I covered, or by itself. Though it can be bypassed if you have a file upload vulnerability. But if you're using immutable infrastructure type methodologies, you're not affected. It doesn't work with containers, which is a bit of a problem, but we're going to solve that. Okay. What could we do in containerized apps, Docker and Kubernetes? You can't use the same technique because of the layer that they use, but we could abuse that Docker instances are ephemeral, so it's like they're just single-use containers. What we do is basically delete all the unnecessary binaries at the build stage, and any remaining binaries, we could delete them using an init system like supervisor D or run it. I didn't have time to prepare a demo for this, but it's the exact same concept. Pros, cons, extremely simple to deploy, minutes, and you can configure it for anything. If you ever do need to run commands in your container, you could always use something like BusyBox. The cons, it doesn't provide you with any type of logging. You'd have to use something like RCE guard to get that. Okay, so how can you correlate alerts that something like RCE guard is giving you, or SE Linux, or AppArmor with the actual web request? You can't directly do that, but there are a few techniques you could use. For example, you could use a timestamp to look at the 2-second range in which a specific web request happened. One possible solution that combines WAF with PubSub and RCE guard is to just have a script that's looking at the output file from RCE guard. As soon as it detects something, it extracts its timestamp, sends it to PubSub, and you have something on the WAF side which actually takes the logs and sends them to your SIM. So you'd only just get those logs. You won't get anything else. Okay, summary. RCE exploits can be defeated. You pick and use the most appropriate approach. Smart defenders use defense in depth, and before buying, leverage what you have. Out of the box, you have a ton of capabilities in Linux, like SE Linux and AppArmor. So this was us before this presentation, and this is us after. So thank you. Questions? Yeah. Yeah.
Okay. Is there any movement in the community to have that support?
It's not something that they're that interested in. And even SE Linux doesn't have container support. They're not that interested. But you could get that with RCE guard. So I'm gonna hopefully I plan on releasing it later this month.
How often do you see companies using OS level security without SE Linux?
Yeah. Lots of people actually do that disable, but that's really that's not good. You could that's why if you invest some time, it's extremely powerful. Do we have time? I could show you how SE Linux can actually, even by default, detect a remote code exploit. Anything else? Yeah.
So with the startup timing, have you considered putting in a hook to like a IP tables block in while it's starting up?
You could do that. Another thing is most services have, for them, you have to pass health checks. So by the time if you're behind a load balancer, by the time you pass it, it's already gone. And it's configurable. You could do 5 seconds. You could do 10 seconds. You just try the application, make sure it works. Okay, it took 20 seconds. That's what I said. Other questions?
Is this idea defined like in process?
Sorry?
Like you spoke a lot about like this in processes, but if you could force like a list LS in process, just in
If it's like a memory corruption vulnerability, it won't detect it. But memory detection corruption is very rare, and an attacker would eventually get it. They won't just their buffer overflow won't have everything they need. Yeah.
what's it look like with cron? If I get 20, it'll be better.
Cron?
Yeah, cron. So let's say I had like a backdoor shell with cron quickly for this.
You wouldn't using which one of these? Sorry.
So RCE guard, like
You have 20 seconds, and most web applications don't allow you to. Tomcat doesn't have cron capabilities out of the box.
As you run a cron command as your payload for RCE.
Yeah, I know. But cron, I don't think Tomcat and most web servers even have permission to run cron jobs.
Oh, gotcha.
Yeah. Go ahead.
are you going to release those videos?
Sorry?
Are you going to release those videos of showing?
Yeah.
Follow-on question to the cron one. I guess the gist of your thing is that 20 milliseconds is still a really long time to process that. There's a lot you can do in 20 milliseconds before RCE kills it.
Yeah, but that's why you could use the other two techniques which block it anyway. So with cron, he won't even the process won't even have access to them. Yeah. Is that clear?
Not really.
RCE guard gives you 20 milliseconds. And then the last two that I covered, as soon as the process is up, before it's connected to a load balancer, I've already revoked access, so there is no cron that it can run.
Right.
And if it was a Docker container, there is no cron binary on the file system.
So if the second one does the job, why does RCE guard need to exist?
That's just how I thought mentally. I went through, because this was like I went through about 8 different techniques. I went through seccomp filters as well, Java Security Manager. Each one has its pros and cons, and it's like, okay, how could I do? I could do that. So you could get away with just running the last 2 techniques, but you'll get 0 visibility. So you don't know if you're under attack or not. It's interesting, and you could also use this to detect even 0 days, because it's like, nothing's detected, but I found a suspicious request, and RCE guard kicked it. Any other questions?
Something for Windows.
Actually, I wanted to. I'm not that great at Windows. I wanted to look at that, but I didn't have time. This took a lot of time, looking at the different techniques and finding bugs as well. But Windows, you might be able to start looking at something like RCE guard using something like Sysmon. Sysmon lets you do process monitoring, but you'd have to add like rules and stuff like that. Is there any Windows kernel experts here that could point us to?
There aren't Windows kernel exports to Microsoft.
No, you do. You have Mark Ruzinovich and a bunch of others. One problem with Windows as well, it doesn't have something like AppArmor or SE Linux. You don't have process transitions. Like you can't say, as soon as a specific process runs, I'm going to apply something else.
But I suppose you could run the application as a particular user and then remove
I thought of that, but I haven't looked into that.
In Linux, you do not get the same effect if you did that.
That's what I do. That's what I did in the second.
If you set up a user, particular user,
Yeah.
and then the executable flag is removed from.
You could try to do that. I didn't have time to look at Windows. And
I'm saying in Unix, you could probably do the same. Add a user to a group and remove the executable flag for that group.
you can't do that at the user level. You do that at the file system level. So, any other questions?
No more questions? Oh, thank you.
Okay, thank you.
Also, lunch is